Okay, so first thing today we're going to review over balancing reactions, work a few more examples. So I want you to write these problems down in your notebooks. And we worked a few yesterday, and we're going to work a few more today before you do a Phet simulation lab on this. We're going to work each day and get to where progressively harder problems. We're going to be starting off with some easier ones first. So in balanced reactions is a review. On the left side of my arrow, I have my reactants. In this case, it would be CH4, which is methane or carbon tetrahydride, and oxygen gas. And on the right side, I have my products, which in this case is hydrogen gas, H2, and then CO, which is carbon monoxide. The arrow means to yield or to produce. And I have, in this case, two reactants and two products. So to balance this, I'm going to use, why do I have to balance reactions? Well, according to the law of conservation of mass, atoms cannot be created or destroyed in a chemical reaction. They're conserved, or mass is conserved. So you have to have the same number of atoms on each side of the arrow. So when your products have to equal your reactants. So what I'm going to do is draw a line down the middle. And in this reaction, it has carbon in it, has hydrogen, and has oxygen. I'll put that on both sides. And I'm going to list the number of atoms on each side. On the left, I have carbon. I just have one atom. Hydrogen, I have 4. And oxygen, I have 2 of those. On the right, I have 1 carbon. I have 2 hydrogens. And I have 1 oxygen. So I'm going to start with, I can start with my oxygens or I can start with my hydrogens. Let's just do the hydrogen first. To have 4 on the right side, I would need to add, remember, when I balance reactions, I can only add numbers in the front of these substances, and these are called coefficients. They tell me the number of molecules, so I can only change that number. And right now, without anything being there, it's understood that it's just a 1. So I need to put a 2 here. That makes me have 4 hydrogens. So my hydrogens are balanced. But my oxygens are not. So I want to go back. And my oxygens, I got 2 on the left. I need 2 on the right. So I'll put a 2 right here. That makes me have, 2 oxygens, but it changes my carbons to 2 also. So you go back to the other side and put a 2 in front of here. That makes my carbons change to 2, but it changes my hydrogens now to 2 times 4 to 8. So then I need to go to the other side now, and I need 8 hydrogens. I need to change that number to a 4, and that makes me have 8 hydrogens, and then this reaction is balanced. Now sometimes you won't have to balance reaction. If you add up all the atoms and they're the same, then you just write balanced. It would just be 1 to 1, 1 to 1. Basically what this reaction says is that when this reaction happens, 2 molecules of CH4 reacts with 1 molecule of O2 to produce 4 molecules of H2 and 2 molecules of CO. Now in this example, if we have like this compound right here, BaClO3 2, that's barium chlorates, and it produces barium chloride and oxygen gas. So it's a decomposition reaction because I have 1 reactant breaking down into 2 products. This is made up of barium, chlorine, and oxygen. Alright, so bariums I have just one. Chlorines I have one on the inside, but I got two on the outside, and two on the outside goes with everything on the inside. So that'd be 1 times 2, give me 2 chlorines. Oxygens be 3 times 2, that have 6. On the right side I got 1 barium, 2 chlorines, 2 oxygens. Alright, so I can only start with my oxygens. Everything else is balanced, so oxygens, to have 6 on the right side, I would need to put a 3 right here, and that would give me 6, and that would balance this reaction. Now this third reaction, this is a combustion reaction because I got O2 as a reactant, and I got CO2 and H2O as products, and a hydrocarbon to start off, C9H20. Hydrocarbons is something made up of carbon and hydrogen. And this is made up of carbon, hydrogen, and oxygen. Now carbons, I have 9 of those. Hydrogens, I have 20. Oxygens on the left, I have 2. On the right side, carbons, I have 1. Hydrogens, I have 2. And oxygens, I got 2 there with CO2, but I got 1 with H2O for a total of 3. Now when I start to balance this, I'm going to balance whatever's easier to start with. I can start with my carbons. I got 9 on the left, I need 9 on the right. I have to put a 9 right here. So that would give me 9 carbons, but it's going to change my oxygens. Now I got 9 times 2, 18, but then I got 1 more with the H2O. So 18 plus 1 would give me 19 oxygens. So next I want to balance my hydrogens. That would be easiest to balance. I got 20 on the left, I need 20 on the right. I need to put a 10 right here. That would give me 20 hydrogens. It's going to change my oxygens. With the carbon dioxide there, I got 9 times 2, 18 plus, and I got 10 more there with the H2O. 10 times 1 is 10. So that's 18 plus 10 gives me a total of 28. Now go back to the left. I need 28 on the left. What times 2 equals 28? And that would be 14. 14 times 2 is 28. And that balances it out. So just make sure if you have something like this, where your oxygens are separated in 2 different compounds, that you pay attention to that when you're adding up your number of atoms. Now, what you're going to be working on is this Phet, balancing chemical equations. When you open it up, it should bring you to this. First, you're going to click on Introduction, and you're going to do like 3 different reactions. First is making ammonia, and what you do is just you click and it's going to ask you to click some stuff up here, like the bar graph or something. Just follow the directions. This would show you if it's balanced or not. But you're going to add a nitrogen into. It shows you a little molecule of nitrogen, and add a hydrogen, and then add a NH3 molecule. And if you notice, they're not balanced. You need to balance these out. So you're going to be changing these coefficients to balance them out. Nitrogens only have 1 on the right. I got 2 on the left, so I'll need to add a whole another molecule of NH3 to balance it out. Remember, I can only change those coefficients there that tell me the number of molecules. Now I have 6 hydrogens. I would need to go back to the other side where I need 6. So I'd have to add 2 more, which balances this reaction. So you can answer the questions you're going to go through with this water, decomposition reaction, and then a methane combustion reaction. Afterwards, at the bottom, you'll click Game, and you'll do each one of these levels where you balance these reactions. And then at the very end of the virtual lab, you just have like 12 reactions to balance.